We will solve now the last 5 problems of the SSC CGL Tier 2 level solution set 18 on trigonometry 4 from suresolve.com. This is Atanu Chaudhary with you. In this session, you will see how the complementary angle, supplementary angle and compound angle trigonometric relations are used when solving these problems. Let's dive in. This is question 6. Read through the problem for a few seconds and then analyze and try to find out how you will solve the problem. Identify that all the 4 functions in the target expression can easily be converted to their complementary functions, and then it is just simple trigonometric simplification. You will use here the complementary angle relations tan 90 degree minus theta equal to cot theta, sin 90 degree minus theta equal to cos theta, cosec 90 degree minus theta equal to sec theta, and cot 90 degree minus theta equal to tan theta. Tan and cot are paired, sin and cos are paired, and cosec and sec are paired. We will have to assume here that theta is an acute angle. Using these complementary angle relations, the target expression is simplified to E equal to cot square theta minus cos square theta whole multiplied by sec square theta multiplied by tan square theta. Now break open the brackets and multiply sec square theta tan square theta with the two terms of cot square theta minus cos square theta. Cot square theta gets neutralized by tan square theta, leaving sec square theta for the first term, and cos square theta gets neutralized by sec square theta, leaving tan square theta for the second term. By neutralization, I mean the product of the two results in 1. So what do we get? Now it is the last but one stage of simplification. The target expression becomes simply sec square theta minus tan square theta equal to just 1. If you are comfortable in using the complementary angle trigonometric relations, you can easily solve this problem in 20 seconds at most. Answer is option A 1. Okay, the next problem now. This is question 7. Read through the problem for a few seconds and analyze and try to find out how you would solve the problem. You have here 4 terms in the target expression, isn't it? The angle pi by 6 in the first term equals 30 degree, and using trigonometric ratio values, you will get cot 30 degree equal to cos 30 degree by sin 30 degree equal to root 3 by 2 divided by 1 by 2 equal to root 3. So, 4 by 3 cot square pi by 6 equal to 4 by 3 times 3 equal to 4. To evaluate the second term, you need to use supplementary angle relation cos 90 degree plus theta equal to minus sin theta, and the second term becomes 3 cos square 150 degree equal to 3 cos square 90 degree plus 60 degree equal to 3 sin square 60 degree equal to 9 by 4. Knowing that cosec 45 degree equal to 1 by sin 45 degree equal to root 2, you get the third term value as minus 4 cosec square 45 degree equal to minus 8. As 8 sin pi by 2 equal to 8 sin 90 degree equal to 8, the last two terms cancel out, and the target expression evaluates to E equal to 4 plus 9 by 4 equal to 25 by 4. Answer is option D, 25 by 4. With a little care, the problem is quite easy after all. Let's see the next problem. This is question 8. Read through the problem for a few seconds analyze, and try to find out how you would solve the problem. If you convert the tan functions to sines and cosines, you will get the sum of two products in sines and cosines. At the next step, it will be easy then to combine these two products by compound angle relations. Sin alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. Sin alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta, and sin 2 alpha equal to 2 sin alpha cos alpha. The third relation you get by substituting alpha equal to beta in the expansion of sin alpha plus beta. Back to solving the problem, let's start converting the tan functions to sines and cosines. Target expression E equal to sin 5 theta cos 3 theta plus cos 5 theta sin 3 theta divided by 4 cos 4 theta multiplied by sin 5 theta cos 3 theta minus cos 5 theta sin 3 theta. Observe that 1 by cos 5 theta cos 3 theta cancels out between numerator and denominator. Using the first compound angle relation we have just jotted down, the numerator becomes sin 5 theta cos 3 theta plus cos 5 theta sin 3 theta equal to sin 5 theta plus 3 theta equal to sin 8 theta. And using the second compound angle relation, the denominator becomes 4 cos 4 theta sin 5 theta minus 3 theta equal to 4 cos 4 theta sin 2 theta. What about the target expression? It is simplified to sin 8 theta divided by 4 cos 4 theta sin 2 theta. This is the time when you use the third compound angle compact relation sin 2 alpha equal to 2 sin alpha cos alpha on sin 8 theta. Sin 8 theta equal to 2 sin 4 theta cos 4 theta. The target expression gets simplified further to 2 sin 4 theta cos 4 theta divided by 4 cos 4 theta sin 2 theta equal to 4 sin 2 theta cos 2 theta divided by 4 sin 2 theta, again expanding sin 4 theta equal to 2 sin 2 theta cos 2 theta. Four sin 2 theta cancels out, leaving E equal to cos 2 theta. Answer is option C, cos 2 theta. Though the steps seem to be many, you should reach the solution quickly. Ninth problem now. This is question 9. Read through the problem for a few seconds, analyze, and try to find the solution. We'll have to again use the compound angle relations. Sin alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta, and sin alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. When we expand the numerator sine functions, cos y sin z cancels out, leaving sin y minus z plus sin y plus z equal to 2 sin y cos z. And in the same way, when we expand the denominator, cos x sin z cancels out, leaving sin x minus z plus sin x plus z equal to 2 sin x cos z. The target expression reduces simply to E equal to sin y times 1 plus cos z divided by sin x times 1 plus cos z equal to sin y by sin x. Answer is option D, sin y by sin x. All in mind and in quick time. It's now time to solve the last problem. This is question 10. Read through the problem for a few seconds, analyze and try to find the solution. You know that by complementary angle relations, sin 90 degree minus alpha equal to cos alpha and cos 90 degree minus alpha equal to sin alpha. So the first term in the numerator is transformed to sin 90 degree minus tan theta equal to cos tan theta. And similarly, the first term in the denominator is changed to cos pi by 2 minus tan theta equal to cos 90 degree minus tan theta equal to sin tan theta. In contrast, for the second term in the numerator and the denominator, you need to apply supplementary angle relations. Sin pi minus alpha equal to sin alpha and cos pi minus alpha equal to minus cos alpha. So, cos pi minus 6 theta equal to minus cos 6 theta and sin pi minus 6 theta equal to sin 6 theta. Substitute these results to simplify the direct expression as E equal to cos 10 theta plus cos 6 theta divided by sin 10 theta minus sin 6 theta. At this stage, we will have to use the third pair of submultiple angle relations. Sin A minus sin B equal to 2 cos A plus B by 2 sin A minus B by 2. And cos A plus cos B equal to 2 cos A plus B by 2 cos A minus B by 2. For the denominator, use the first relation with A equal to tan theta and B equal to 6 theta. You will get sin 10 theta minus sin 6 theta equal to 2 cos 8 theta sin 2 theta. And for the numerator, use the second submultiple angle relation with A equal to tan theta and B equal to 6 theta again. You get cos 10 theta plus cos 6 theta equal to 2 cos 8 theta cos 2 theta. Ratio of these two results gives you the answer. E equal to 2 cos 8 theta cos 2 theta divided by 2 cos 8 theta sin 2 theta equal to cot 2 theta. Answer is option D, cot 2 theta. If submultiple angle relations seem to be an extra load for you to understand, just assume A plus B by 2 equal to alpha and A minus B by 2 equal to beta. Adding the two, you get alpha plus beta equal to A, and subtracting you get alpha minus beta equal to B. Use these results on compound angle relations. Sin A minus sin B equal to sin alpha plus beta minus sin alpha minus beta equal to 2 cos alpha sin beta equal to 2 cos A plus B by 2 multiplied by sin A minus B by 2. And cos A plus cos B equal to cos alpha plus beta plus cos alpha minus beta equal to 2 cos alpha cos beta equal to 2 cos A plus B by 2 multiplied by cos A minus B by 2. Overall, none of these 5 problems should be difficult for you if you are clear about the complementary angle relations, supplementary angle relations, compound angle relations and the submultiple angle relations. You can go through these concepts as well as the solutions in more details in the corresponding articles at suresolve.com. The links are given in the description of this video. Lastly, please do subscribe to our channel for latest uploads. Thanks for watching.